So here we come to IGCSE 2023 October and November Additional Mathematics Paper 1 Set 1 question number 7. So this term is about differentiation, so we need to differentiate it. But before that, let's take a look on the function f of x. Here it's made of two products, the red one and the blue one. So maybe we need to think about the product rule I just write here. All right, but some students may think that, oh, can we just break down the function f of x and then further differentiate it? Actually, we can do it that way, but let's take a look on here. The f prime of x, the question asks us to write it in the form of 2 times 3x minus 2 and then times another bracket. So we need to do some factorization. So I would suggest you to just use the product rule. So let's do it. For the red one, if we differentiate 2x plus 1, it will just give you 2, right? How about the blue one? The blue one here is 3x minus 2 to the power 2. So we need to use the chain rule first. So it will be equal to 2 times 3x minus 2, and then further differentiate the bracket. It will be 3. This is the derivative of the blue one. So now we can differentiate f of x. All right, for this f prime of x, using the product rule, it will be equal to the red one times the derivative of the blue one, which is 2 times 3x minus 2 times 3, and then plus the blue one. The blue function is this one, 3x minus 2 to the power 2, and then times the derivative of the red function, which is just 2. So this is for the step 1. And then remember, we need to factorize out the 2 and the 3x minus 2, these two factors. So consider these 2 to be taken out. The front one will give you 3 times 2x plus 1, and the later part will give you just 3x minus 2. So we need to simplify this one, or for the whole bracket, you give something like this, 6x plus 3, and then plus 3x minus 2, and then further simplify it, you will have the answer. F prime of x is actually 2 times 3x minus 2 and then times 9x plus 1. Or compare with this, p is actually 9 and then q will be positive 1. So this for part A. So we come to part B. We need to find the coordinates of the stationary points on the curve. So here, just the stationary points. We need not to find if it is maximum or minimum. So for stationary point, the f prime of x must be equal to 0. So we just get f prime of x from part A. So just substitute it in, the whole thing will be equal to 0. And then we know that is a quadratic equation. Each factor should be equal to 0. So it will give you 3x minus 2 should be equal to 0. And this will give you x must be 2 over 3. Another answer for the x should be 9x plus 1 will be equal to 0. And the x should be negative 1 over 9. But remember, this time we need to find the coordinates. So we need to also find not just x, but also y. And here we need to substitute the x, these two x values into f of x again. Remember, not f prime of x, but f of x to find the original point. So here, for the first one, if we substitute 2 over x into x, it will give you, just 0. You just use your calculator to do this. And then how about the next one? If you substitute negative 1 over 9 into the f of x, it will give you 343 divided by 81, or just some decimal numbers is still okay. But remember, we need to write down the coordinates. So there are just 2 stationary points, which are, the first one is when x is 2 over 3, the y should be 0. And the other one will be when x is negative 1 over 9, and then the y should be 343 divided by 81. And this is for part B. So now we come to part C. This time we need to sketch the graph of y is equal to f of x, and then indicating the intercept of the coordinate axis. So how about we just find the intercepts first. For the y-intercept, we need to substitute that x to be 0, and then using our calculator, y should be equal to 4. So let's mark this down on the plane. So it should be somewhere like here, right? X is 0, y is 4. Okay. And the next, for the x-intercept, we need to substitute that y to be 0. So this one is already factorized. So we know that 2x plus 1 must be 0, or 3x minus 2 must be 0. So it will give you two values of x, which is negative 1 over 2 and the 2 over 3. So just write these 2 points. It should be somewhere here. And then the later one should be negative 1 over 2 and then 0. So we got 3 points, but we also have 2 points in part B, which is 2 over 3 and 0. Oh, it's just the same as one of the x-intercept. But we need to check if it is maximum or minimum later. And then another one is the green one from part B. Here we need to compare it with the y-intercept 4. So for 343 divided by 81 using the calculator, it is something like 4.23. So this green point should be a little bit higher than the blue one. So I will write here for the this green one should be negative 1 over 9 and then comma 343 divided by 81. So we have got 4 points here. But okay, we need to check these two stationary points, the purple one and the green one, if they are maximum or minimum. So how do we find it? We need to differentiate f prime of x again. I differentiate it using the product rule, and then simplify the bracket, and then further simplify it, you will have something like this. Alright, so the second derivative of f of x should be 2 times the bracket 54x minus 15. So now we can substitute the value of x into the second derivative to check if it is a maximum point or minimum point. For the purple one, x is 2 over 3, so we just substitute it inside, and it is a positive value, which is 42. It is larger than 0, so this point must be a minimum point. So I will draw something here. We should see something like this for the purple one, this one. And then how about the green point? Alright, we substitute negative 1 over 9 into the second derivative, and then you will get something negative, or negative 18. Just use your calculator. So this one must be a maximum point. Alright, so this one we should see something like this. So now we can just link it together. The whole thing should be like this. Alright, because of the minimum and the maximum. So this is the graph for the y is equal to f of x. And this is for part C. So now we come to part D. Alright, here we need to find the values of k, such that the equation f of x is equal to k has 3 distinct solutions. So what does that mean? We have already got one black curve, which is y is equal to f of x. So just imagine we have one more line, where this line is y is equal to k. And y is equal to k, it must be a horizontal line. So imagine this horizontal line, we move it upwards. Right? When f of x is equal to k has solution, it means this black curve and the purple line will have intersecting point. Or just like here, we have one intersecting point, meaning for this value k, we'll have just one solution only. So when it comes to here, meeting these two red points, you will have two distinct solutions for f of x is equal to k. And then later on here, you will have f of x is equal to k having 3 distinct solutions. But when does it end? When the k is going up again until it meets the green point, it will be having 2 distinct solutions, and then later on it becomes 1 again. So the range of k should be in between this and this. So we need to think about this range. k should be in between these two values. All right, so for the upper one, this one should be 343 divided by 81, and the lower one should be 0. So the value of k is actually in between 0 and 343 over 81. Now remember, we cannot have equal sign here, right? Because when it is equal, when k is equal to 0, it has just two distinct solutions, but not three. So this should be the values of k. And this is for question number 7. Thank you.